let's start with a question that might surprise you. How many subsets can a set have? Take the set A equals 1, 2, 3. How many different subsets can you make? Let's count by group. So first, 0 element. It gives us what? 1 subset, right? Then 1 element. That one we're going to get what? 3 subsets. 1, 2, and 3. Then 2 elements is going to also give us 3 subsets. So here we have 1, 2, 1, 3, and 2, 3. Then we have the full set. So let's count them together. 0 elements gives us what? 1. Then here we have 1, 2, 3, making 4. Then here 1, 2, 3, making 7. Then the whole set 8. So 8 subsets. But why 8? And could we have predicted that without listing everything? Let's try and understand the pattern. So here's a key insight. When building a subset, for each element, you make one simple decision. Do I include this element? Yes or no. That's it. 2 choices per element. So you're going to try it yourself with A equals 1, 2, 3. Trace through building one subset. Then we do it together. Now let's see every possible combination laid out. Okay, we're going to use a table to do this. So we are going to ask ourselves, simple yes or no question. Do I include you or do I not include you? Right? So first we begin. No. Or no. That gives us the empty set. Next one. Do I include 1? Yes. Do I include 2? Yes. Do I include 3? Yes. So these are the single elements. Right? The single elements. Then, let's look at a pair. Do I include 1 and 2? Yes. What about 1 and 3? Yes. Then 2 and 3. Yes. Now, do I include the full set? So you see, at every point, do you notice what's happening here? Yes. So we are just asking, do I include this? Yes or no? Do I include that? Yes or no? Okay. Now, let's connect that pattern directly to the formula. So we saw that what? Element 1 had 2 choices, yes or no. Same for element 2, then element 3. Okay, so what we are doing here is that we are multiplying all these what? 2 choices. So 2 by 2 by 2. And what do we have? 8. So you are multiplying 2 by itself once for each element. Because every element contributes exactly 2 options. That's why the formula is 2 exponents n, not 3 exponents n, not n exponents n, but always 2. Because the choice is always yes or no. Do we see why that works? So the formula is 2 exponents n. Let's run, some examples. All right. So now you know why, right? You know why we have 2 exponents n. So the number of subsets equals 2 exponents n, where n is the number of what? Elements. So 3 quick examples. Say n equals 2. How many subsets? 4. What about n equals 4? How many subsets would we have? 16. Great. And if n equals 5? 32. So every extra element doubles the count. That's exponential growth. Quick check. A set with 3 elements has how many subsets? Before we move on, quick check. Exactly, 2 exponent 3, and that is what? 8. Good. So now that we have...
Before we continue, if you're enjoying this lesson, there's a lot more waiting for you at SageCube Academy. We have live online classes, full lesson notes, tutorial videos, WASSCE past questions, practice exercises, flashcards, and more. All in our study app. Visit sagecube.org today to register. The link is also in the description below. Now, let's get back to the lesson.
So now, what if we only want to count the proper subsets? Right? What if we want to count only proper subsets? We know what a proper subset is. Any subset that is not equal to the original set. So you're going to use our yes or no logic. The only subset that isn't proper is the all yes option, the full set itself. So for A equals 1, 2, 3, we had 8 total subsets, remember? Yes, we had 8 total subsets. So we are going to remove the full 1, 2, 3 subset, and then we'll have what? 7. Okay, so for proper subsets, we remove the full one. We always what? Remove that one full set option. Does that make sense? And what if the question, flips it, giving you the number of subsets and asking for n? If it flips it, right? So sometimes you are given the number of subsets and you need to find n. The approach is ask, what power of 2 gives me this number? You know your powers of 2, okay? So 2, then raise to the power 2 before 3, 8 to the power 4, 16, power 5, 32, like that, 64, 128. So that if I give you an example that a set has 32 elements, how many, it has a 32 subsets, how many elements would that be? Good, you know that what? 2 exponents 5 gives you what? 32. So that means the n equals 5. Therefore, it has what? 5 elements. Are you with me so far? Let's put both directions into practice with a worked example. So how many subsets does a set P equals 2, 4, 6, 8, 10 have? How many subsets? Just pause the video, try it out, and then let's do it together. Good. So we are going to count the elements, right? How many elements do we have here? 1, 2, 3, 4, 5. So P has 5 elements, okay? So the number of P here, 5 elements. Good. We are going to understand the logic. Each element can be in or out of a subset. So we have 2 choices each. So the total combination will be what? 2 exponent 5. And that will give us 2, 2, by 2, by 2, by 2, 5. What do we have? 2, 2, 4, 4, 2, 8, 8, 2, 16, 16, 2, 32. So we're going to have 32 what? Subsets. Okay. So that's if you're going to have 32 subsets. Let's go through together. Yes. So we realize that P has 5 elements. 1, 2, 3, 4, and 5. So the number of elements equals 5. So we are going to use our formula, but we understand the formula now because every element there has 2 options. Do I include you or do I not? So in or out, in or out, in or out, in or out, in or out. So 2 choices each. That's going to be what? 2 exponent 5. So for each element, 2 options, 2 options, 2 options, 2 options, 2 options, right? To get it, always 2 choices, yes? So that's how we have what? 32 elements. Okay, so let's see work example 2. Set Q has 64 subsets. 2 things to find. How many elements does Q have and how many proper subsets does it have? So we know what we are going to do here. You pause the video, try it out, then I walk you through it. Good. So we have 64 what? Subsets. So we know that 2 exponents n is giving us what? 64 what? Subsets, right? So we can express this as what? 2 exponents what? 6. Then from indices, because they are equal, it implies that what? Our n here is 6. Do we get that? Good. Now, how many proper subsets do we have here? Proper means that we have to take away the full set, the last one, the one that has all the what? 6 elements. So we are going to have our 64 minus 1, exactly. So 64, let me break it here, minus 1, and that's what? 63 proper what? Subsets. So we have 63 proper subsets. Let's go through together. So we saw that question said we have 64 subsets. So 2 exponents n is giving us 64. We express them same base, and we know that what? It's going to be what? 6 elements. In other words, you should know these in your head. 2 exponents 1, 2, exponent 2, 4, 2 exponent 3, 8, as we saw early on, okay? Then now if you have to understand what proper subsets are. The set must not be equal, so we always remove that full set, since that's what is going to violate the proper set rule. So when we take that out of it, we are going to have what? 64 minus 1, and that equals 63. Okay, so great. Let's look at it in real life. Let's step outside the maths classroom and see this formula in action. So a pizza shop has 4 toppings: pepperoni, mushrooms, onions, and peppers. How many different pizzas can you order, including plain? Right, so here for each topping, you're going to have what? Yes or no. Sound familiar? Good. So plain pizza is what? The empty one. Then just pepperoni is what? Pepperoni. Just mushrooms, just onions, just peppers. Then you can have, double combination. Pepperoni, mushroom, pepperoni, onions, pepperoni, peppers. Have what? Measured up 3. Pepperoni, mushrooms, onions. Do we get what is happening here? Good. So here we have what? 4 toppings. So we know that we are going to what? Because we have what? 4 toppings, we are going to have 2 exponents, what? 4. And that's going to give us what? 16 different pieces, what? Possible. Okay, and it's not just pizza. This pattern is what? Everywhere. Okay, look at this example we have here. 5 accessories. Wear each or not. You have hat, scarf, your watch, bracelet, sunglasses. Okay, so if you look at the combinations, you're going to have 2 exponent 5, and that's 32. You are doing 6 elective courses, right? We are taking elective math, physics, chemistry, biology. Maybe you're adding what? Computing to it, and let's add a 6th one, econ, right? So the combination that we are going to have here is going to be what? 2 exponent 6, so 64 study what? Combinations. Okay, you have what? 8 toggleable settings: your Wi-Fi, Bluetooth, whether you have to what? Turn on notifications or not, airdrop, all these kind of settings. You get it. We're going to have 2 exponents 8, and that's what? 256 configurations. What if you have 10 smart players? Include or not, that's going to be 2 exponent 10, whether you include this player or not. That's going to be what? 1024 possible teams. Do you get that? So same logic every time. Count the items, raise 2 to that power. Then real life combination problems. There are subset problems that have been disguised in real life. So these things are very, very practical and not abstract. Okay, let's test your understanding with 4 quick questions. Quick check. So pause and let's walk through all of them. 1. A set has 3 elements. How many subsets does it have? So it has 3 elements, right? So our n equals 3. So then how many subsets? And that's 8, right? 2 exponent 3, and that's what? 8. Then our set has 16 subsets. How many elements does it have? So we know that this time we know that the 2 exponents n is what? 16. So it's going to be what? We just express this in the same base. And it's going to have 4. Yes, it's going to have 4 elements. How many proper subsets does A, B, C, D have? Proper subsets. So we already know 4 from here will be 16. Right? So 2 exponents 4, we have 16. But proper means what? Proper means we have to subtract the full set. So 16 minus 1, and that's what? 15 proper subset. And the last one, the empty set has how many subsets? Explain why. Use the yes or no logic. The empty set. Yes. So let's see. So the empty set has what? There's no element in there. So our n, first of all, our n equals 0. So 2 exponents n will be what? 2 exponents 0. And that's what? 1. Yes. So the only subset here is what? The subsets. So the only subset of the empty set is going to be what? It's going to be that empty set. So it's going to be just this one. All right. Good. So that's all for land. One more special case worth its own slide. Okay, so these are the ones that we just did. We realized that what? For 3 is 8. For 4 is 16. Right? They gave us a 16 for us to find the number of elements. So it's just simple what? Indices there. Then here we have 4 elements. So we're going to have what, 16 total subsets. But proper means you take the full set out. Then for empty, it has 0 elements. 2 raised to the power 0 equals what? 1. So the only subset it has is itself. Yeah. Then this is a special case that we're talking about. So how many subsets does the empty set have? Let's think through this carefully. So we realized from the previous example that it's going to be 2 exponent 0, which equals 1. And that's exactly what? Itself. Okay, so the empty set is a subset of every set, including itself. Does that make sense? Does that click? Yes, because if I look at the elements inside it, there's nothing in there. So the very first thing is that if I'm listing what? Every set, we begin by listing the empty set. So even for the empty set as well, when we are listing the what? Set, the subset, we begin by listing that what? That empty set. Let's look in everything we've covered with a clean what? Summary. Okay. So the big idea, building a subset equals making a yes or no choice for each element. With n elements, that's what? 2 exponents n total subset. So the formula total subset equals what? 2 exponents n, and our proper subset would be what? 2 exponents n. Then we subtract 1 from the final answer. 3 things to remember here. Powers of 2 from 2r to 128. They are your toolkits for reversing the formula. Remember that the null set is always a subset. They're all and a no choice. Okay, and real life combinations are subset what problems in this, guys. Alright, so check yourself against this 9-point checklist before you move on. Check to see if you can what? Do all these. If you can explain the reasoning behind each one, not just the answer, then you genuinely what? Own this topic.